Hello, this is Gio. Hey, look what we have here. This is a Powerstat variable auto transformer, and I just picked this up just a couple of days ago. It wasn't working. I'll show you kind of what I did to fix it up, but I just kind of wanted to show this off and show you what these things do. I did put it on some foam here just to protect the table a little bit more. But again, this is a Powerstat auto transformer. Now it is a transformer, so it transforms voltages inbound voltages of, in this case, 120 volts, and you can transform it into basically anything you want from 0 volts all the way up to 140 volts. Now you might notice that it's extremely large and it is actually pretty darn heavy, and it does look pretty old. And this auto transformer is fairly old. It's I'm not quite sure how old. It's probably possibly from the 50s, etc. But they make these auto transformers almost identical to this today, perhaps with some more modern frontages. But basically what you see here now is basically what they're selling today. And I've zoomed in here to the label, and this one was made by Superior Electronics, and they still make the same kind of auto transformers today. This one is model number 116, and again, you could find similar 116s from Superior Electronics today. I think they have C or D little numbers in the back of it, but you could still buy the 116 today. And so what are these used for? Well, basically they are to control voltages. So the inbound voltage of 120 volts in this case can basically be transformed to anything you want, from again 0 to 140 volts. Now, since the inbound voltage is a little bit lower than the maximum, which is the 140 volt, typically anything over 120 volts, you could still get the voltage, but the current does get reduced a little bit for any voltages above 120. And this could be useful for a variety of purposes, from, let's say, if you have equipment that you want to run at a different speed. I'm going to bring a belt sander to kind of demonstrate that a little bit in just a second. You could also control, these are very useful in, let's say, radio equipment, and also I think like lighting situations. These can basically be large dimmer switches. These are not dimmer switches. These act differently, but you can control lighting, you can control machinery, you can speed up and down equipment, or you could just, if you need very specific voltages that you need to modify, you could basically set this to the exact voltage you want and let the equipment or device run at that voltage. So again, I do have the belt sander that I mentioned here, and it is plugged in, and this does not have variable speed. So once you hit the trigger here, right here, the belt sander just starts running at its normal speed, which is this, with no variable speed. But with the auto transformer, we can actually get better control on this belt sander. And so I did lock this belt sander on the on position. I plugged it into the auto transformer. We'll go ahead and hit the switch to the on. It is 0 volts right now, and as I turn this on, you'll start hearing it wanting to run. You can hear it kind of wanting to, you hear a little bit buzz. And there you go. Now normally this would be just spinning really fast, but because we're controlling the voltage, it's going at a much slower speed. And if you want to do more controlled work with sanding, you can do that here, or you can speed it up. To its normal speed. And so to better demonstrate what's happening with the transformer, I have my multimeter here. I'm going to set it to volts, the AC volts. Anytime you're testing AC current, You want to make sure that it is on the AC and that the range, let me just set the range appropriately. There we go. And so unfortunately the plug end here doesn't really fit my probe, so I'm just going to use a little extension cord. I'll go ahead and plug this end in. And so this will be my test point right here. I have my black and red leads here. So I'll go ahead and stick one in that and one in the other, just like that. And so we turn it on and we start turning on our transformer, increasing the voltage, and you can see, if I could lift this up, the voltage is increasing as I move the dial. And if I move it all the way up, it will go to close to 140, and we got 140.5 here. Now this dial isn't that precise. I sort of calibrated the dial top here, so it at 60 volts, I think it pretty much equals the voltage here. But as you can see, if I go down to 20 on the dial, it shows about 17.9, and if I go to 120 on the upside, if I can aim properly, that matches pretty well. Let's try 80. 79. So it's pretty close. Up higher, down lower, it might be a little bit off. But so if you're going to use precise measurements for these auto transformers, I do recommend using a multimeter. So if you want precise, let's say you want something 45 volts, you just want to turn it until you get the steady 45. And there you go. And as you can see, the voltage is pretty darn consistent. It's kind of wavering a tenth of a volt there, probably because I don't have it perfect. But you can see once I release the dial, it is pretty darn consistent, and it'll stay that way for basically as long as you want to use your equipment. Now, although this can be used for lighting and is commonly used for larger scale lighting, like lighting sets for a movie or TV situation, but this is not a dimmer switch. Now, typically in your little wall outlets, you see dimmer switches. And what dimmer switches do, if you think about an AC kind of a sinusoidal wave, as you can see here, now the autotransformer will reduce the voltage and increase the voltage, but you'll maintain that constant sine wave that you see. It won't really, you'll basically get a perfect sine wave still, even though you're modifying the voltage. Now with a dimmer switch, what a dimmer switch does is it actually kind of cuts the wave on one side or both sides of the sine wave, and so you don't get a pure sine wave on the AC current. It'll actually cut it on one or both sides. So so if you want that pure sine wave, you definitely want to use an auto transformer. Now you might be asking why it's called an auto transformer. You might be saying, well, is it for auto mechanics? Well, no. The auto part in the name is Greek for self. So auto in Greek is self, and that basically means it has one coil. So many transformers actually have two coils. The inbound current has a coil, and then it's transformed with a secondary coil. This one actually only has one coil, and I'll show you, I'll open this up and show you how that works. So one of the disadvantages being a single coil, it does have a disadvantage. It doesn't isolate these primary and secondary currents like two coils would, and so that could be a problem if you're using it for sensitive equipment. And quite commonly, people who use these as power supplies for sensitive equipment, even radio equipment, etc., they usually have another device to help protect from the surges that could potentially occur with the primary power supply. Now it does have a fuse right here, and I could show you right there as it pops out. Just like that, that's the fuse. And if the fuse blows, it won't work. You'll need to replace it. So if your auto transformer doesn't work, that would be the first step to see if that fuse is good. And to test it, you just want to take your multimeter, set your multimeter to continuity. So when you touch the probes, it makes a little beep or it kind of signals you in some way, so you know you have a continuity. And you just take one probe, touch it with one side of the fuse, the other side, and since I'm getting a beep, it is there is continuity, and so this fuse is not blown, and so this fuse is good, and that's how you test the fuse. Okay, and so to take this thing apart, it is unplugged. First, let's take the dial cap off. There's a couple of screws right here that basically holds it to the main rod, and so we'll just twist these out. Just like that. And this just kind of loosely fits on this main rod here. And so when you replace this, you want to just test it out and turn it on and use your multimeter and make sure that if you're measuring 20 volts, you want to make sure that it's in the right position like that. I calibrated it to the 60, and so I set it to the 60 volts and then tightened up these screws. So that's how you put this cap back on. And then to take the main cover off here, there's several, I think 4 screws on the side, 1, 2, 3, 4, I believe, that we need to remove. And also we need to loosen this top one right there, just a bit. So we'll loosen that and then remove all of these screws. And then this cap just comes straight off. Okay, so what are we looking at? So what we're looking at is, this is the core right here, and you can see the coil windings around it. Basically all these little wires that surround the core. And this is basically a continuous wrap of wires from the beginning, which you can see right here. That's where it starts, and that's where the coil ends. And then up on top, you have the shaft right here that kind of holds this. This is the bushing wheel here, or the bushing holder. And the actual bushing is right here that comes in contact with the exposed wires of the coil. Now the wires on this side are insulated. They have, kind of like an insulation around them. But up on top, they are exposed. And basically the bushing, which is right here, makes contact with the exposed wires that are up on top. Now I can remove this little bushing holder with just an Allen wrench here. There's just 2 little screws right here, so we'll take one off, and then we can just remove this entire thing from the rod. And that's what it looks like. And so the bushing, which is right here, that's in contact with the wiring, basically connects to this wire here, and then that connects to this little wheel here, which is basically a contact, which contacts these 2 little connections there, and that connects to this wire. And so I did say that when I originally got this, it wasn't really working properly. It really wasn't, it wasn't really working much at all for controlling of voltages. And basically what I had to do, it was basically the exposed wires to the winding here. As you can see, it's kind of shiny copper right here. Well, that was basically black when I got it. And so I had to use a little sandpaper. And so I just kind of sanded off all that black and exposed all these nice shiny copper wires. And that basically, the black carbon that was on top of that was basically preventing the bushing from being in contact with the wires. I also sanded a little bit these contacts here that you can see they're still a little dark in the middle, but I just sanded those a little bit. And I also sanded this ring, which was also very blackened, and there was very poor contact between these contacts and these rings. So that's basically all I did. Now, one thing to test the coil. So if you do take your multimeter and put it into continuity mode again, if sometimes these coils burn out, and if they burn out, they usually lose continuity. So one way of checking to make sure that the coil is good and that the machine can actually work is to just put it on continuity, go to the start of the coil and the end of the coil, touch again you want to touch the exposed portions, not these portions here, but if you touch here and here, and those are in continuity, you know that the wires are fully connected all the way around and they haven't burnt out. So as long as you're in continuity between the first and end, your coil winding should be good. Okay, so how does this transformer actually work? So basically, you have your inline power here. So that goes into this little box. I could open this up, but it basically, it's basically connected to the fuse, it's connected to this outlet, and it's connected to actually 5 little terminals. And 4 of those 5 terminal connections are connected actually to your winding. You can see this little piece right there. So this is a little wire, and I believe this is from terminal 5, and this actually connects directly into, there's a little exposed portion of the winding wire here, and so this terminal 5 is connected here. On the other side, I believe that this is terminal 2 right here. So this is also connected to a different location in the winding. And if I were to remove this little panel here, you would see that a similar little connection here connected to the first winding of the coil. Now terminal 3 in this box is actually connected to this wire here, which again goes through here, is connected to these little contact points, which goes to this ring that goes to the bushing, and that connects into the coil. Now, so your incoming power, again, you have 2 prongs here. You have a hot prong and a neutral prong. Now your neutral, your negative, is actually directly connected to your terminal 1. So your neutral little connection is actually connected to your first winding, the first wind of your coil. And as you can see from the top of the cover here, where your terminal 1 is, that's 0 volts, okay? So that would be the neutral position. And at your terminal 2, that's the 120 volts. So that is the 120 volt inline current from a typical house. Now the 140 volts, again, that's a step up voltage. Your current actually reduces when you go up, stepped up. You do get the full 140 volts, but slightly less current. That's actually connected to your terminal 4. And your terminal 5 is somewhere, I think, around 20 to 30 volt location. Now for this particular model, the 116, the terminals 4 and 5 are actually not connected to anything. So it's only the terminal 2 and the terminal 1 that are connected. Now your incoming neutral or negative end, which is connected to your terminal 1, is also connected to your neutral side of the outgoing power. So it's not only connected to terminal 1, but it's also connected to your neutral end of your receptacle. And the hot end of your receptacle is actually connected directly to terminal 3. So if I can get this down. So when your bushing hits the wind, whatever voltage comes from that bushing into your wire here and into your terminal 3 will come out here. And so I will demonstrate this by plugging it in this configuration without the bushing connected. I'll just make sure that everything's in place. I'll go ahead and plug this in. I will not touch this by hand once it's plugged in, and then I'll show you exactly what's happening with this coil once it's plugged in. Okay, so I have my transformer plugged in. It's off, but I have my multimeter set to AC voltage. And so I will demonstrate, once I turn this on, there. And so again, terminal 1, the neutral, is connected to the first winding of your coil, which is right over here. And then terminal 2 if I could turn this around, is right here. And so that would be about the connection point right here. And so if I were to put one lead on the terminal 1, here, let's set up the multimeter here, just like that. And then the other lead around where terminal 1 or terminal 2 comes in, it should be about 120 volts. Well, let's see if I raise it up a little bit. There, that's 120 volts. So basically what I'm measuring is basically from neutral, the incoming neutral, and the incoming hot, which is the 120 volts. So again, those are your incoming, your plug is basically connected. Your neutral is where this black lead is, and your hot at 120 volts is where the red lead is. And so how the transformer works in terms of transforming the voltage, again, you have your bushing that goes around this, and your plug, one of your outgoing plugs are connected to the terminal 1. So the other end is connected to wherever that bushing is in contact with this coil. Now, again, I have my leads here. If I were to put one on the first wound, which is that terminal 1, the neutral, and touch the other end, basically at the same place, I'll basically get 0 volts, okay? But now if I were to move up the winding from 0 volts, basically as I go up, the red lead is starting to see higher voltage. And as I go all the way up to the 120, you will see it just increasing all the way to 120. So basically, as I go up the winding, I'm increasing the voltage to the maximum voltage of the 120. And I could also step up all the way to 140, all the way up to here. And so that's basically how this is working. You basically set a neutral point here and a 120 volt point here, and then anywhere you tap into the coil along the line is just a fraction or percentage of that voltage. And there you go. That is how a variable auto transformer works. Now, the wiring could be slightly different with regards to those terminal setups. You can see here, depending on the voltage rating of your unit, they could be wired slightly different, but the concept is all about the same. Well, I hope you enjoyed this video, and if you did, please hit that like button at the bottom of the screen, and even consider subscribing to my channel. I have many more videos to come. Bye-bye.